Here's a quiz that you should all pass. What virus has been eradicated from the wild through public health programs and vaccination? Take your time if you need any. The answer I was looking for was smallpox. However, that's not the only answer anymore. Big bonus points if you can identify the viral pathogen that we are waving goodbye to this year. I'll get to it later. How did we eradicate wild smallpox? It had been one of the worst diseases in human history, vying for that title with bubonic plague. It shaped the colonization of the New World and virtually exterminated whole peoples. It periodically resurfaced in rural areas to kill and reinfect. There are a few things about smallpox, though, that made it easier to eradicate. Let's go through them. 1. Vaccination was highly effective and practical. The vaccine was a heat-stable, dead virus conferring long-lasting and almost complete immunity. People only needed one dose and they were safe from infection. 2. Survivors usually had lifelong immunity. 3. The disease is relatively easy to self-diagnose. Scars mark those who were previously infected and therefore resistant. 4. There is no animal vector that maintains smallpox in the wild. Cowpox is a related virus, and there are hundreds of other pox viruses, but smallpox only infects humans. 5. The disease must be transmitted by direct contact rather than blood, sex, water, air, or insect transmitted. 6. No silent carriers or subclinical cases exist. People had frank disease if they were infected. Compare this to HIV, where silent carriers are a major source of new cases. 7. Short incubation period. People could be quarantined for a short time if they were exposed. Longer quarantines are harder to manage. 8. Very little viral diversity. Only one serotype ever existed. 9. There was a lot of public support for the effort. The number of dead in each outbreak was usually quite high. So people who knew of the virus were willing to be treated, and governments saw smallpox as a disease worth spending money on. 10. Pox viruses are very large DNA viruses. That means they evolve a lot slower, and most of the innovations or new functions they acquire are stolen from the host cells. The emergence of new strains is much slower, which means a single vaccine can be very effective over long time periods. In the war on disease, vaccines are the pinpoint guided missiles tipped with thermonuclear warheads. They are incredibly powerful because they prevent the disease from being transmitted using an adaptive system, your immune system. Every substance you are vaccinated against creates a population of special immune cells that exist to remember the bad guy. A vaccine is like giving your immune system a PhD in defeating a particular pathogen. There are some disease agents that have properties that make vaccines less effective. For example, HIV is a fast-evolving RNA virus. It has a long incubation period and a high rate of silent carriers. It has a high viral diversity. Most importantly, it infects the very cells in the immune system that show up when a virus is detected. Activating the immune cells can actually accelerate the progress of disease. Back to the new development. What virus has been handed its hat and shown the door? Well, you might be disappointed, but it's not a human pathogen. It's a pathogen of cows called rinderpest. It's an especially nasty one, sometimes called by the literal translation of the name, cow plague. It's popped up rather constantly over the last 4,000 years. It usually wipes out the entire population it emerges in, nearly 100% lethal in the infected animals. The vaccine for it wasn't developed until the late 90s, and it's taken a relatively short time for concerted efforts to completely eliminate the virus, except for research stocks in a few labs around the world. In 2001 in Kenya, the last confirmed case was treated with quarantine. Vaccination efforts continued until 2006, but no evidence of the disease has been found in disease surveillance. We now live in a world where, at least the cows, can sleep a little happier at night, knowing their lives will not be cut short by this ancient and lethal disease. Now, why do we live in a world without rinderpest, but with its cousin, measles? Why did chickenpox, rubella, mumps, HPV, HIV, viral hepatitis, and influenza continue to kill and maim unchecked? In some cases, it's the challenges of the biology. In others, it's a sociological or political economic issue. I think if there is one legacy we can leave to our descendants, a world with less disease and suffering is a realistic and achievable goal. When I view vaccine denialism or anti-vaccine movements through the lens of opponents of a better future, it's hard to be very sympathetic to their concerns. Their motivations are self-interest, and the people they hurt most haven't been born yet. Our actions now set the course for the world of the future. We can't let irrationality and pseudoscience lead us to darkness. Thanks for watching.
Every cell of each plant and animal contains genetic information coded onto the DNA molecules. The model